These are the Chapter 4 Notes 3 on straightening power models. Today what we're going to take a look at is what do you do if your data is not linear and it's not exponential either. And that's going to be our focus today. Specifically, we're going to look at whether or not your data is linear, exponential, or follows what's called a power model. Now, a power model is simply an x squared graph, an x cubed graph, maybe it's x to the 4th power graph. It's basically a model that you could set up using y equals x to some power. Now, to determine if data is linear, this is a series of steps that we went through on our last chapter as well. You had to go through it yesterday on your homework assignment, and we'll kind of go through it again today. Typically, if data is linear, your first step is to input your data into lists in your calculator. Specifically, you're graphing x and y values, which traditionally we put in list 1 and list 2. We then follow it up by doing lin-reg to get our least squares regression equation, r and r squared. Of course, this is the equation y hat equals a plus bx. The next thing we do is we put the residuals in your calculator in list 3 and graph your residual plot. Specifically, we're continuing to graph the x values, but instead of graphing the y's, we're going to graph your residuals. Again, usually your residuals are in list 3, so this is a graph of L1 and L3. And your final step, we evaluate this residual plot. If you see a curve pattern in your residual plot, that means your data is not linear. Random scatter, on the other hand, means that the original data is linear, and usually that also means we're kind of done with the problem. However, we saw yesterday that sometimes the residual plot shows a curve pattern, so we check to see if the data is exponential. If the data is exponential, what we're going to graph are the x values, and we're going to take the logarithm of the y values. This traditionally will bring your steepness of your graph way down, and we've put your log of the y values in list 5. So you may recall we go to list 5, we take log of L2, the y values, and we put them there. When you generate your least squares regression equation on your calculator, since we're no longer dealing with y values but log of y values, we likewise see a log of y hat at the beginning of your equation equals a plus bx. When you get down to the residual plot, you're going to continue to graph your x values. We're going to put new residuals in your calculator in list 3. And again, we're going to graph the x's and the residuals. These are new residuals based off of this new equation. But similar to the last problem, it's L1 and L3 we're going to graph. If you now see a random scatter of the residual plot, that means the graph of the x's and the log of the y's were linear. But it also means that the original x and y data follow an exponential model. Now, yesterday, either the data was linear or it was exponential. But there's the possibility that the transform graph here, this residual plot, might also show a curve pattern. And if that's the case, what we do is we try our third model, which is called a power model. And for a power model, not only are we going to take the log of the y values to bring them back, but we're also going to take the log of the x values. We're just going to bring all this data much closer, and this typically will allow us to straighten out our data. So if neither of the first two models give us that linear pattern we want, then we're going to log both the x and the y values. And usually what we do is I'll put the log of the x values in list 4. The log of the y values should still be in list 5. Now what we've done is we've utilized all the lists. X's and y's are in list 1 and list 2. Residuals I'll always put in list 3. Then I'll put the log of the x values, the log of the L1 values in list 4. The log of the y values are in list 5. How does that change our equation? Well, when you do the lin-reg step, not only are we taking the log of the y values, so our equation starts with log of y hat, but we're also dealing with the log of the x values. So in your equation, it's going to be a plus b times the log of x. This time when you graph your residual function, we keep the same kind of x list that we just worked with. That's the log of the x values. So when you go back one last time to your stat plot, we're going to leave the x list alone. We're still going to leave L4 in there, but we're going to put new residuals in. This is the third set of residuals we're going to have to calculate. They're going to go back in list 3, and we're going to graph L4 and L3. If you finally have a random scatter of the residuals in this residual plot, your third residual plot, it means that the original data is a power model. If the residual plot is curved at this point, make sure you haven't made any errors, because at this point, one of these types of models should straighten your data out. What we're going to look at today is some data that's on page 220, and it deals with the heart rate and length of cavity of left ventricles for assorted animals. We're going to look at what type of model best fits this data. Is the data linear, exponential, or follower power model? So we're going to input the data to compare heart rate versus length of cavity. Remember, when it's written in this versus form, the heart rate is going to be your y variable, which we're going to put into list 2, and the length of cavity will be the x variable. So again, in list 1, that's going to be the length of cavity, and in list 2, we're going to put the heart rate. What I'd like you to do is I would like you to go through the first 2 steps on this worksheet. The first step is doing the linear model. This is exactly what you did in chapter 3 on your last test. We did this a number of times yesterday. Sketch the L1 and L2 values, come up with the equation, residual plot, patterns. Then for the exponential model, the same types of categories. X and Y values, least squares regression equation, residual plot, patterns that you notice. Then we're going to move on to what's called the power model. With the power model, you're going to have to take the log of the x values. Remember, that goes in list 4. And the log of the y values should be in list 5. And you're going to run through essentially the same kinds of steps. Work with your classmates, help each other out, and go through those first 3 types of models. Once you get done with those 3 steps, check your solutions. There'll be an answer sheet in the front of class. And then we will come back and talk about this latter part tomorrow in class. So for tonight, you don't have to worry about this part. This is a way of transforming your data. We'll deal with that tomorrow. Your focus today, go through the linear, exponential, and power models. Determine which model is best. Work together. Check your answers when you're done.